Okay, so today what we're going to talk about is the natural base. So I'd like you to put me on pause, try this, and then come back and check your answer. Okay, so hopefully you found the E button on your calculator. The E button is right above the division symbol, so you need to hit second and then the division symbol. See the little blue E? So when you plug that in your calculator, you get 2.71828 ... And what I know about this is that this is an irrational number. E is an irrational number. So it goes on forever, cannot be written as a fraction. All right, so now what E is used for? E models things in nature, so the natural world, and in manufacturing. So when I have the function f of x is equal to e to the x power. E, which is my base here, that's called the natural base. So remember when I did my other exponential functions, f of x is equal to a to the x power. My a, which is my base, that's a rational base. Now, plug in your calculator y equals e to the x power. The graph looks exactly the same as all the other graphs. It looks like this. And it goes through the point 0, 1 because all exponentials go through 0, 1 because when x is 0, your y value will be 1. Okay, so now E can be approximated by the function f of x equals 1 plus 1 over x raised to the x power as x goes to positive infinity. So as I plug in positive x values as they go to positive infinity into this equation and I evaluate, my number will get closer and closer to this number here, the 2.71828. So I'm going to show you that. So we're going to start with f of 10. We're going to evaluate. So what you could do is you could take the function, this function here, 1 plus 1 over x to the x power, put into y equals, and then you could do the alpha trace button and evaluate. All right, so I'm going to do 1 plus 1 over 10 raised to the 10 power. So plug that in your calculator to get 2.59374 ... All right, let's do f of 100. So it's 1 plus 1 over 100 raised to the 100 power, which is 2.70481 ... And already notice I went from 2.5 to 2.7. See, I am getting closer to this number here. So now we're going to do f of 1,000. So it's 1 plus 1 over 1,000 raised to the 1,000 power. So plug that in your calculator, you get 2.71692. Getting closer. All right, let's do f of 10,000. So it's 1 plus 1 over 10,000 raised to the 10,000 power. And that comes out to be 2.71815. Okay, it's getting closer. Let's do f of 100,000. So it's 1 plus 1 over 100,000 raised to the 100,000 power, which comes out to be 2.71827. See how close I'm getting? I'm at 27 and I'm here at 28. Let's do f of 1,000,000. So 1 plus 1 over 1,000,000 raised to the 1,000,000 power. And this comes out to be 2.71828. See how close I'm actually getting. As my x value is increasing to positive infinity, I'm getting closer and closer to this number here, base E, natural base E. All right, so now what I want you to do is go into y equals, clear out anything you have in there, and I want you to put in y1. I want you to put in f of x equals E. And in y2, I want you to plug in g of x is equal to 1 plus 1 over x raised to the x power. And I want you to graph it. And as you graph it, your first thing is going to be your E. So that's 1, 2, 3. So here's your E. Y equals E, f of x. And then plug in g of x, and g of x looks like this. So notice that my g of x is getting closer and closer and closer to base E as my x values are increasing. So let's just write this down over here on the side, because we did not write it down before, that as x goes to infinity, the function f of x gets closer to E. Okay, so let's take a look at the bottom. Okay, so this is just evaluating. Use your calculator for this. So plug in your calculator, e to the negative 2 power. So e to the negative 2 power is 0.135335 dot, dot, dot. Remember, it's irrational. Plug in e to the 10 power. It's 22026.46579 dot, dot, dot. Remember, irrational. E to the point raised to the 0.25 power is 1.28402 dot, dot, dot. Okay, so let's flip it over and take a look at the back. Okay, so I have an application here. It says the approximate number of fruit flies in an experimental population after T hours is given by the equation Q of T equals 20E raised to the 0.03 T, where T is greater than 0. So T is the number of hours, and Q of T represents the population of fruit flies after T hours. It says find the population at the start of the experiment. How large is the population after 47 hours? How many hours will it take for the population to reach 500 flies? All right, let's start with number 1. Find the population at the start of the experiment. All right, so at the start of the experiment, what do I know? I know that my time, T, is equal to 0. So I'm going to do Q of 0. So I'm going to plug that in, and I have 20E raised to the 0.03 times 0 power. So Q of 0 is equal to 20. So there are 20 flies at the start. All right, let's take a look at number 2. How large is the population after 47 hours? So I want to know when T is equal to 47, how many flies are there? Well, after 47. So I'm going to do Q of 47. So I have 20E raised to the 0.03 times 47 power. So plug it in your calculator, and you get 81.919, which would be 81 flies after 47 hours. Okay, so let's try 3. Okay, so 3 says, how many hours will it take for the population to reach 500 flies? So I want to know when Q of T is equal to 500. I want to know when the population is 500. I want to find the time. I want to find my X value when my Y value is 500. So let's graph. Let's graph Q of T equals 20E to the 0.03 T power. And then we're also going to graph Y is equal to 500, because I want to know when is my Y value going to be 500 for this graph. And then I want to find the point of intersection. All right, so I'm just going to move everything up a tiny bit. Okay, so plug both into your calculator. You're going to have to adjust the window. Okay, so put me on pause, adjust the window so that you can see the entire graph. All right, so hopefully you adjusted the graph, and you had to have negative 100 on the left, 100 on the right, 200 to see nice picture, negative 100 down here, and then I did 100, you need 200, 300, 400, 500, 600. I would know I have to go up to 500 because I want to know when my Y value is 500, right? So I want to know this. I want to know when my Y value is going to be 500. So when I graph Q of T, so I know at 0, it's going to go through 20. So it's going to look like this. And so now I want to know, when is my flies going to be 500? So I want to find that point of intersection. So do second calc. Number 5 is intersect. Okay, and this comes out to be 107.29586, comma, 500. So 107 hours for the population to reach 500 flies. Okay, so that's it, and we'll practice in class tomorrow. Have a good night.